Let's get our journal all updated. So go to your Teach Tracker and we are going to highlight the skills that we just finished on the last unit. I am on page 2. So we just finished linear regression and scatter plot, and that is on reporting category 2, 4A, 4B, and 4C. Go ahead and highlight those. 4A, 4B, and 4C. And that completes reporting category 2. Yes. So I'm going to go ahead and box this in and shade it because we finished it. That's reporting category 2. And we have also finished reporting category 3. See how all those are highlighted? Go ahead and highlight the whole reporting category 3 box. So there are 5 categories. We have completely finished 2. So we're going to keep on rolling through it. You also need to go to your test tracker, and we have done Unit 5 and Unit 6. Go ahead and put your grade for Unit 5 and 6. Okay, so now you need to go ahead and make a pocket on the next page of your journal. So these were my last 2 pages for Unit 6. So we're going to do Unit 7. Go ahead and make a pocket. And then put in your unit divider in the next page. We are going to start Unit 7 off with this skill right here. Simplify numeric and algebraic expressions using the laws of exponents. Okay? So all of Unit 7 is about exponent rules and exponential functions. So we're going to start out with this skill. So we are going to learn all about exponents. So we have a problem string we're going to go through, and this problem string is just a bunch of problems that will help us come up with a general rule that explains how multiplication and exponents work. So let's go ahead and just write a raised to the b power. A is the base. I'm going to just leave my highlighters open because we're going to use them a lot. And b is the exponent. So we have base and the exponent. The base on mine, I'm going to highlight the base the same as A, and the exponent the same as B. All right, so remember with exponents, what it means is repeated multiplication. So if I have 4 to the third, what this means is 4 times 4 times 4, because it's 3 times, repeated multiplication. So I'm going to go ahead and highlight my exponent orange, because that's the color I picked, and then my base. Yep. So 4 to the third means we're going to multiply 4 times itself 3 times. So 4 times 4 Or we can actually do 4 to the third in the calculator. So let's review how to get 4 to the third in the calculator. We're going to do 4, and then right underneath the clear button is this little, what I call carrot top. You're going to do the carrot top and see how it takes it up to the exponent, and then put a 3 in there. Go ahead and make sure you know how to put exponents in the calculator. 4, the little carrot top, the 3. Push enter. It is 64, which is the same thing as doing 4 times 4 times 4, right? They're equivalent. So make sure you know how to put those exponents in your calculator. So your calculator should be on your desk right now. All right, let's do the next one. 4 squared times 4 to the first. Let's highlight the exponents and highlight the bases, the other color. See how this has like bases? Like bases mean they're the same base. So these are like bases. So this is going to mean 4 times 4, right? Because that's 4 squared. And then times another 4. So 4 squared is this 4 times 4 is another 4. Which we already did that, right? 64. Right, equals 64. So these are the same. 4 to the third is the same thing as 4 squared times 4 to the first. All right, let's go to the next one. I'm going to change bases. I'm going to do 3 to the fourth. Go ahead and highlight your exponent in your base. 4 squared means 4 times 4. And then 4 to the first times another 4. Yeah, that's the first power. 3 to the fourth power means 3 times itself 4 times. These are not the same because they're different bases, different exponents. So let's think this through. What's 3 times 3? What's 3 times 3? So then 9 times 9, 81. Let's make sure we can check that, verify that. So do 3 raised to the fourth power. Make sure you can do that correctly. And yep, it is 81. Let's do 3 squared times 3 squared. Highlight your exponents and your bases. These are like bases. They both have 3s as their bases. So let's go ahead and expand this out. 3 times 3, all right, because that's 3 times 3, times another 3 times 3. I'm breaking it down, expanding it out, and then go ahead and do 3 times 3 is 9, times another 3 times 3 is 9. 3 squared is 9, right? Times 3 squared, another 9. 9 times 9 is 81. You seeing a pattern? Yeah. Yeah, these are the same. 3 to the fourth, 3 squared times 3 squared. All right, we're going to change up exponents again, variables again, not variables, with these bases. There we go. 2 squared times 2 to the cube. 2 to the third. So let's break it down. This would be 2 times 2 times a 2 times 2 times 2. So then we're going to go ahead and multiply it. 2 times 2 is 4 times 2 times 2. I'm going to like expand it out slowly. What's 2 times 2? 4. 4 times another 2 is 8. Yeah. 4 times 8, 32. And you know we can put this in the calculator. The reason we're using small numbers is so we can do it in our heads, but we can show it in the calculator. So go ahead and do this with me. 2 raised to the 2. Put it in your calculator because I want y'all to work through this with me. I need to put in times 2 to the third. So the way you get down from here, so see how it's in the exponent? It's in the superscript. Push the arrow over button right here. And that brings it back down to a base. Then do times 2 raised to the third. Make sure you can do this in your calculator. Should equal 32. Up in the exponent and you want to come back down to do your operation and to do another one, make sure you push the arrow to the right. If you mess up, push clear and try again. All right, so that does equal 32. Right, let's do 2 times 2 to the fourth. If this doesn't have an exponent, what is the exponent? No, what is the exponent for 2? 1. If there is nothing there, automatic, it's a 1. So this just means 2 times, because that's the 1, and then 4 of them. So this would be 2 times. Now we got to do this in our head. So let's work it out. You ready? 2 times 2 is 4. What's another 2 times 2? What's 4 times 4? 16. What's 2 times 16? 32. Yeah, these are the same. Okay, so how are these the same? What do you notice about the exponents? 2 and 3, and then 1 and 4. Yeah. So what I'm going to write is 2 to the 5 equals to the 2 times 2 to the 3, because we can add those. They have bases that are the same. We add our exponents. And what about 2 times 2 to the 4th? Yeah. What's 1 plus 4? 5. So this all equals 2 to the 5. Add exponents, right? So I put how, add your exponent. So 2 to the 5 is 32. These are all the same. I'm going to highlight these. Let's look at these real quick. 3 to the 4 is the same thing as 3 squared times 3 squared. How is that? Because you add them. So 3, 2 plus 2. I'm going to write it like that. What I'm doing is I'm adding these. Equals 3 to the 4th power. You can have plus in the exponent. So I looked over here. 3 to the 4th is the same thing as 3 squared times 3 squared. They both equal 81. The reason is because you can add those exponents. And then this other one, 4 to the 3rd, and then 4 squared times 4 to the 1st. Those are the same also. 4 third, 4 to the 3rd is the same thing as 4 to the 2 plus 1. Yeah, the exponent could be negative. And we're going to talk about that as we go through the next couple of notes. All right, so if we know this, if we know that whenever you have like bases like this, you can add your exponents. Let's do a really big one. So I don't want to do 54 times itself 15 times. And I don't want to put it in the calculator either. So we're going to simplify it and keep our same base, 54. So see how these are my exponents, 15 and 8? But we have like bases of 54. You keep your like bases and you just add your exponents because I would have 15 54s, 3 54s. How many 54s would I have? 18. So I would do 15 plus 3, which is 54, 18. So I know we're using numbers right now, but we're going to start using letters. So that's why you can't just put it in your calculator and come up with, like a number like 32. We're going to just simplify it and keep it with its like base. See how all of these have 54? That's how you can do them because they all have the same base. So let's do a to the 3rd times a to the 5th. So we have like bases. So there's 3 of them here, 5 of them here. So how many total am I going to have? Yeah, 3 plus 5, which gives us, so this means there's 3 of them, there's 5 of them, so we have 8. So let's write a rule for this. This will always work. Add exponents when you multiply like bases. That's our rule. You're going to take your blue paper, you're going to fold this over to the dotted line right here. Crease it. Multiplication properties of exponents. Over here. Okay, now you're going to cut off right below. See this dotted line? You're going to cut right below that, all the way across. And then you're going to cut off this right above the title. It says product of powers, and this is going to be the foldable that we are going to use. Then you'll cut these tabs. And we are going to do the top one, product of powers. For any number A and all integers M and N, so A is any number, M and N are the exponents, you are going to add your exponents as long as you have like bases. All right, so let's do a couple of problems on the inside. It says y times y to the fifth. So when there's not an exponent, go ahead and put yourself a 1 there. So this would be y 1 plus 5, which is y to the 6th. Just do that expansion and we're writing 1 plus 5 on this one. You don't have to do it on the ones from now on. Just do it on this one. Y 1 plus 5 is y to the 6th. All right, let's look at the next one. M squared times M7. Like bases, we're going to add those. So it's going to be M to the 9. All right, now we have a mixture of different variables. We have an R and an N. So what I like to do first is put ones on anything that doesn't have an exponent. So R1, N1, R1, then we have an N3, N2. So let's go ahead and look at it. So I'm going to look at all the R's. I'm going to put the R's right next to it. R1, R1, that's it, right? Those are all the R's, R and R. Then I'm going to do all the N's. So I'm going to put a double line underneath all the N's. So it'd be N1, N3, N2. They have to be kept separate. You can't combine them because it's just like combining like terms. They have to be the exact same base. So I've expanded or I've reorganized it so all the R's are together, all the N's are together. So I have R1 and R1, makes it R2. And I have N1, N3, and N2. So I add those up. 1 plus 3, 4, plus another 2 more is 6. Yep. You can put times or you can just leave it without any kind of operation because any variables right next to each other represent multiplication. All right, we have 2 more examples. I want to reorganize these also. So let's put -4. Anytime you have numbers, go ahead and just put them in parentheses. We add them 1 plus 3 plus 2. So we have a 4, -4, and -5. So I'm going to put those out front first. Then, yeah, x3, x7. So we'll go ahead and multiply -4 times a -3. Just regular multiplication. We're not changing anything. -4 times a -5 is a +20. If you need to, put that in your calculator. And then your x's are 3 plus 7. Yeah. The next one. I'm going to look at my constants first because the constants should always be out front, and then your variables are after that. This one has j and k, -3, +2. All I did was pull them out front. Oh, if I have a j squared and then just a j, there's a 1 there, right? Which j to the first power. And I have k4 and k6. So -3 times 2, -6. J squared and j3, right? Because I have 2 plus 1. And then k4 and k6. 4 plus 6, 10. All right, you're going to use this to do your assignment, and your assignment 1 through 12.